Okay, I am going to talk about average value of a function, but I can't help but talk a little bit about the mean value theorem. And if you remember from way in the beginning of the year, the mean value theorem dealt with derivatives, and it said this. So the mean value theorem said that you have some function and you have an interval, let's call it AB, and the function has to be continuous and differentiable. And what we said is that if you took the average rate of change, that there would have to be some place on this function where our derivative would be equal to this average rate of change. So I would guess it might be like right there. Okay, so what we're saying is there exists a value of c in the interval such that the average rate of change, so f of b minus f of a over b minus a, is equal to f prime of c, right? The derivative is equal to the average value. Now, here's the thing. I also could call this function capital F of x. And if that's the case, well, it just means capital F of b minus capital F of a over b minus a is equal to f prime of c. But you know where I'm going with this. This f prime of x, well, that's what we used when we talked about taking an antiderivative. Remember we said that was going to be capital F of b minus capital F of a, where, again, capital F prime of x is little f of x. So this really is going to be equal to some f of c, right, if the relationship is the same. Okay, so here's where we can go with this. So this mean value that we used for derivatives, well, let's go with, again, this capital F of x, but we're going to define it as we have before as the antiderivative between a and x of some f of t function. So still using that mean value theorem for derivatives, I'm going to say that there exists some c value in the interval that we have, which is a to x, such that the derivative of this big F function is going to be equal to, well, f of x minus f of a over x minus a. But here's the deal. F of x minus f of a, you know that that really is equal to this definite integral. So that's a to x f of t dt over x minus a. And what we said about this is that it's just going to be f of c. So just using the mean value theorem for derivatives and what we know about the fundamental theorem of calculus, we get this, which looks like, and in fact is, the average value of this function, f of x, over the interval. Okay, so that's the mean value theorem connection.